Hi Rohan.
Hi, Bia. Am I audible?
Yeah.
Okay.
So let's start. Like this will be a 40 minutes interview. So in
Okay.
that, we'll try to cover two DSA questions, and
Okay.
your like expectations from you is to write the pseudocode for both the questions.
Okay.
If time permits, then we'll go with the proper code.
Okay.
Okay. So let's start with the quick introduction. I'll start with myself. So myself, Jatin Agarwal. I have currently joined Kotak Mahindra Bank few days back. Before that, I have worked with Amazon and Zomato also. So I have around 1.5 years of experience, majorly in backend. And
Okay.
exact, currently, 2 or 3 days back only, I have joined Kotak Mahindra Bank as an ISD. So yeah, uh,
Okay.
so you can also brief
So,
yourself.
my name is Rohan and I'm a final year BTech student from Delhi Technological University. I am pursuing my BTech in engineering physics with a major in electronics and minor in computer science. Apart from it, talking about my skills, I'm a Munch-Tech web developer
Mm-hmm.
and I also love doing competitive programming. I have solved around 1,000 plus problems, DSA problems on various platforms.
Mm-hmm.
That's
Oh, nice, nice. Yeah, so I'll paste the question, or I can like type the question in the whiteboard also. Once I type the question, then you can open any of your ID or your notepad in local and you can share your screen. So
okay.
let me share my screen first. Are you able to see my whiteboard?
Yeah, it's visible.
Okay. Okay. So suppose you have an array of size n. Now,
Okay.
suppose the element are like this: 1, 2, 3, 4, 6, 7, 4, 2, 0, -1, anything. You have to tell
Okay.
me at which index peak element is there.
Okay.
What do we mean by peak element? Suppose if there is any element for which the left element and right element is smaller than current. So, and in the array, there can be multiple peak elements. You have to return any one, like any one index.
Okay.
So, suppose in this array, like 7 is the peak element because 6 is the smaller than 7 and 4 is also smaller than 7. So, 7 is the peak element.
Okay.
So, you
And
have to tell me the only one index which is peak.
so there can be an element. I mean, is there any element that is there any array that
Sorry,
there could be an array also, or there will.
uh, I lost you
What I
actually.
mean to say is it necessary that the array will definitely have at least one
No,
peak
no, no,
element?
no, no. It's not necessary. If suppose if array doesn't contain the peak element, then you have to return the -1.
Okay. Okay. Great.
Mhm.
And can you
So
tell me something about the range of n?
n can, like, as of now you can assume that n, whatever approach you are thinking, there will be no issue of time complexity. So as of now you can
Okay.
think
Okay.
that there is no constraint on n as of now. So you can share your
Okay.
screen and you can open any notepad you want.
Okay. Okay. Just a minute.
Mhm.
I think I'm disabled from sharing my screen. Can you allow me?
Yeah, let me do that. Yeah, now try. Yeah, I'm able to see your
My
screen. Yes, yes, yes.
okay, great.
Mhm.
So let's first take the input n, and I'm taking the input.
Mhm.
So I'm just thinking that brute force will run perfectly in this case. So what I'm thinking is
Mhm.
I will start on the array from the index 2 if I'm taking it one based. From the second element, I will start iterating and compare the adjacent elements. If at any index the that my current element is greater than it than both of its adjacent elements, then I
Mhm.
will return that index. So that will be the peak index.
Okay.
So let
Mhm.
me code it once.
Also, let me tell you one more thing. So for the
Yes.
first index and the last index, you can assume like for
Okay.
the first index, there is minus infinite in the left, and for the last index,
Okay.
there is
Okay.
minus infinite in the right. So those can be also the cases.
Okay.
Mhm.
So it means that first and the last index can also be the peak element.
Yes, 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 yes.
Okay. Okay. Great. Okay. So I will start from the index 0.
Mhm.
Since the left of the first index is minus infinity,
Yeah.
so the first index will always be greater than infinity. So it there is no need to compare it with it. So I will if I equal to 0.
You can write the pseudocode. You don't have to write. First, tell me the approach. Like your approach sounds good. You can write the pseudocode. Uh, like in this
Uh,
case, in this question, pseudocode will be the similar as the original code. So you can write original also. But like in the next question, you can write
like
pseudocode first.
what I'm at the first index or at the last index, I will compare it with the only the one neighboring element that is present. If it is greater than the neighboring element, then I will return the index. If I am
Okay.
in the middle of the array, then I will compare it to the right and to the left. If the current element is greater than both of its neighbor, then I will return that index. It's simple
Okay.
brute force.
Mm-hmm. Yeah, you can write the code.
It's is there mentioned that it should be strictly greater or it could be greater
Yeah,
equal?
it should be strictly greater than.
Okay. So that's the code of this problem. Should I run it?
Let me see it. So what you are doing, you are taking an input, then you are traversing the array, and then don't you think that this code has some edge cases which this code this code will fail on those cases?
I'm at so if I'm at index 0, I will compare it only with the next element. And if I am at last index, I will compare it just before the last index. Okay, else. Okay. So if no value is returned, I will return -1. I think that was the only missing case.
Again, think about it like there is also one case which is missing.
Okay, I think it should run fine.
Okay, so I'll tell you like, so what if the array has size of one only?
Okay, if array has size, okay. Yes, we got it.
Hmm.
Yes, in case when the size is one, then both the neighboring elements will be minus infinity. So we will return the only the first element that is present.
Okay.
I
Hmm.
think it should work fine.
Hmm. Okay. Okay. Yeah. Don't need to run it. I think it's fine. So
Okay.
can you tell me the time complexity and space complexity of this?
So city is simple. We are using only one for loop. So time complexity will be order of n, and space complexity will be order of 1, since we are not using any auxiliary space.
Okay. So can you reduce the time complexity? Like, do you think that it can reduce?
Mm, I don't think so. We can reduce the time complexity further.
Okay. Okay. Uh, like think in binary search like kind of thing.
Okay, just a
Think in
minute.
that way. I'm not saying exactly think in that binary search way, but think in that way, like whether you can do some of the, you can remove some of the cases, since I am telling you that you only have to return one index only. If I
Okay.
tell you that you have to return all the peak indexes, then this would be the solution. But if I'm telling you you have to
Okay.
return only one index, then you can think about this, and because you have to return only one index, so you can just ignore some of the indexes or some of the elements.
Okay. I'm thinking. Yes. I
Okay.
need some time.
Yeah, sure. Like, tell me what kind of
Okay.
thing you are thinking
So
as of now.
yes. So what I'm thinking is, so what I'm thinking is not exactly binary search, but it is something like binary search. Like
Hmm.
first, I will find the mid of the array,
Okay.
like what we do in binary search. We first from start to till end, we will find the mid element. Then
Okay.
I will compare its adjacent.
Okay.
Uh, so by this, I will see like uh, what will be my next window that in which I have to search. So
How will you
If
see
my
that? Like,
current is that I am thinking, so
mm,
if my current element,
okay.
uh, so there could be, I think there could be two cases when I am uh, towards up of a slope or when I am in the downward direction.
Can you before this at 176 line, can you explain me with the example? In 176 line, you can write one example. Suppose there is an array one, 2, 3,
Yes,
4,
four,
5,
five,
4,
four,
1,
four,
7,
one, 7.
10. So can you explain me in this example?
Okay, so like initially my starting pointer would be pointing at 1 and ending point in the mid element. I think mid will come at 5.
Mm-hmm.
So in this case, it is the peak element, so I will return it directly. And let's
Okay, then make the last four to 6.
okay.
Yeah.
So like I found the mid and mid is at 5. Now I will compare 5 with both of its adjacent. See,
Okay.
here 5 is greater than 4 and
Mm-hmm.
but it is smaller than 6. So peak element would be towards 6. So I will iterate in the right of 5 in
Okay.
this window. And there could be another case like suppose
Where
mid element
where
is 1.
where it is in the decreasing order, right?
Yes, yes, like suppose in the next window mid element is 1. I will compare it with its adjacent.
Mm-hmm.
So yes, in this case, I can see that it is smaller than both of its adjacent. So I can go in any direction. Because peak element would be in both direction.
Okay. Okay.
And when there will be a case when my mid element is smaller than the right element and greater than the left element, and I will search towards the left in my left window.
Okay. Okay.
That is what I'm thinking.
And what will be your answer? Like, how will you return? Like, what you will check?
I will uh, answer will be my mid because I am applying binary search on my indexes.
Okay.
So
Okay.
that is what I'm thinking. So should I code it?
I think it's fine. Like, because if you okay, let's code it. Like, it will take only 3 to 4 minutes. So yeah.
Code would work.
Sorry.
Uh, Pseudocode would work, or I should code the
Yeah,
full.
pseudocode will also.
Okay. So this condition would remain same when n is the 1.
Hmm.
So like starting would be I would choose 0 and I would choose my ending element as n minus 1.
Okay.
Then simple a simple binary search while starting is less equal to ending. I will find my mid. Now there could be three cases like when mid is uh, when my element at present at mid is greater than a of mid plus 1.
Mm-hmm.
So in this case, I can see that my current element, like uh, like the right element is greater than the current element.
Mm-hmm.
So my peak element would be towards the right. So I will uh, I will move my starting pointer to the right of mid, and
Mm-hmm.
if it is opposite, like a of mid is less than a of mid plus 1, and a of mid is greater than a of mid minus 1. It means I am at the downward slope. So my peak element would be towards left. So in this
Mm-hmm.
case, my ending pointer would be pointing at mid. And if I found my mid element, then a of mid would be greater than a of mid minus 1, and
Mm-hmm.
a of mid would be greater than a of mid plus 1. In this case, I have found my mid, so I will simply return my mid index. And else there could be a condition when my mid element is smaller than both of its neighbor, like
Okay.
when I'm at the lower downward peak. So in this case, I can move in any direction. So
Mm-hmm.
in the else case, I would just do s equal mid plus 1.
Mm-hmm.
I think it should work.
Don't you think there is an edge case also?
I'm just thinking about it.
Mm-hmm.
Edge case. Yeah, there could be some edge cases like when mid plus 1 is not valid or when mid minus 1 is not valid.
Okay.
So
Okay. Yeah.
for
That's
that,
what I
what
was.
what I can do is I can in the starting and the ending of my array I can put some infinitely smaller element.
Mm-hmm. Okay. Okay. Got it. Mm-hmm. Okay. So what will be the time complexity for this?
So since in every iteration I am dividing my array by half, so
Mm-hmm.
it is similar to the time complexity of binary search, that is log n, logarithmic of n.
Okay. Okay. Yeah. Sounds good to me. Let's move to the next question. So, let me share the whiteboard again.
Should I
Oh, no,
stop
no, no.
sharing this?
Actually, I can tell you I can tell you here also. So you are given a linked list.
Okay,
You can write in the line of 179. You can write the example. So you are
okay,
given a singly linked list. So it will be one. Then you can say arrow,
yes,
two, three, four, five, and then five will end on two. Like five pointer. The
acha,
next of
okay.
five will be two.
Uh,
Yeah, so
like
you
cycle,
can
there
you
is
can
cycle.
write two actually. You can write two, and we will assume that this two is same as. And then you
Okay,
have to find whether a linked list is having a circle or not.
okay. So,
Mhm.
okay, so there is a singly linked list.
Mhm.
4. We have to find whether there is any circle present or not. Okay,
Yes, yes, yes. Like in this case, there is a circle. Like five is connecting to two,
yes,
so
okay. So what I'm thinking is I will iterate over the linked list, and I will take start my head pointer from 1, and I will take one temp pointer. Okay, so what I'm thinking is like like maintaining and visiting array. Like if I'm currently at some element, I would mark it as visited, and during my iteration, if I encountered the same node once again, and if it is all for sure, so that is how I am thinking.
okay. So what will be the time and space complexity for that?
Like it depends on the number of elements I am having in my
So
linked
assume
list,
that number of elements is n.
and so it should be, I think, order of n, since I will be iterating once only,
Mm-hmm. And
and
space.
Space would be, I think it should be order of one only since I'm not using any extra space.
But you told me like you will take some kind of visiting array.
Oh, yes, yes, yes.
Mhm.
So if I'm taking some kind of visiting array, then it would be order of n, like number of elements in the linked list.
How will you store the node itself in array?
Okay, so that is what I'm thinking. How can I store it?
Okay.
It is a, okay, it is a single directed linked list, right?
Mm-hmm.
Just give me a minute.
Yeah, sure.
Like what I'm
Mm-hmm.
thinking is I can store the address of the I can store the address of the node in my hash map, like something like hash map.
Okay.
So that is what I'm thinking is
Can you explain in
like
the
I
next line
can
like how you will store? Suppose you are given a pointer of the head, uh,
okay.
then how and what you will store in hash map?
What I think I like something like set or hash map would work. So like I am taking a set, so I will store the uh, like I'm storing the node in the set like
Okay.
this.
Okay. Then set itself
Then
will
it
take log n to insert and find, right? So
yes.
so how the time complexity will be of n?
So in this case, time complexity would be order of n log n, I think. Yes, it would be order of n log n.
Okay. Okay, so can you reduce it a little bit?
Like I can reduce it if I am using something like unordered set or like unordered map.
Okay, then
Then I think it's time complexity. There, I think I can eliminate that log n factor by using that.
okay. But space complexity will still be of n, right?
Yes, yes.
Uh, can you reduce that also like
Okay,
uh,
just want to. Um, what I'm thinking is like. Like there is uh, what I'm thinking is I can take two pointers. Like I don't need to store the nodes, every node in my set or map. I can take two pointers. Like there is a technique known as like there is a slow pointer and there is a fast pointer.
okay,
And so at every iteration, slow pointer would move to the next node, and my fast pointer would move to the next node. Like slow pointer, let's suppose slow pointer is moving with the speed x, so my fast pointer would move with the speed 2x.
okay,
So at some point, there would be a case like my fast pointer would be equal to the slow pointer.
okay,
So if if that happens, then I can say that my device no cycle is present.
Okay, can you write the code like uh, for that?
Should I make the like all
You can
the
assume
class
you can
also?
assume that a function is given to you where
Okay,
this void sol you can assume that node pointer sol the function name where you will
okay.
return the node itself, the pointer of that node itself, and in the input or argument you will provide the head pointer. You will be provided the head pointer.
So in the head pointer, okay.
Sorry?
Yes, I got it. I'm having the head pointer. So
Yeah,
what
you
I
can
will
assume
do
that you
is,
are having the head pointer. Yeah.
so I will I will take two pointer. One is start, which is
Okay.
equal to head, and other pointer like I would name it slow. Then
Okay.
I would run my for loop.
Hmm.
The condition would be so my fast pointer would jump two elements and my slow pointer would jump only one element.
Okay.
So at any case, if fast is equal to slow, then I can say cycle is present.
Okay.
And if I came out of the for loop, then I can say if cycle is present, I will return from here only.
Hmm.
So if I came out of my while loop and then I can say that there is no cycle present.
Or you can return -1 basically.
Yes.
Okay, so
So I
what will be the time and space complexity in this case?
so since I'm iterating on the linked list, like I'm iterating with the two pointers simultaneously. So my
Hmm.
time complexity would be in the worst case would be order of n only,
Hmm.
and space complexity would be order of one because
Okay,
I'm using
so
only two
hmm.
constant space only.
Do you think that this code will work for sure for every case?
Yes, it should work. It will work. Uh, I can do some dry run also if you want.
Okay, so let me tell you the case. What
Okay.
if there is no next pointer of fast? So your while loop will give you an error.
Oh, yes, yes. So there could be one edge case like I think it would work fine now.
Okay, so what you are doing? You are just taking and you are just checking with the next and next to next,
Yes.
and then okay. So what you are doing here is uh, you are going directly next to next, right?
Like my fast pointer is going from next to next,
Mm-hmm.
and my slow pointer is going only to next.
Okay, okay.
Like condition for slow pointer in the while loop because fast pointer is already already far away from the slow
Mm-hmm.
pointer, so it is already checked.
Okay. So you are there should be no condition on the slow pointer, right?
Yes,
According to you.
yes,
Okay. Yeah, I think this is fine.
yes.
I am not able to think any edge case as of now which will break this code. Yeah, so for slow pointer, the fast pointer should have gone through.
Like a
So
fast pointer would be already ahead of
yes,
slow
yes, yes,
pointer.
yes, yes, yes. So there will be no condition for that. Yeah, yeah. I think it will work. Yeah. So that's all, Rohan, from my side for today's interview.
Okay.
Let me stop the
Should I
recording.
stop? Okay.